Definition of the derivative. We just covered the definition of the derivative. And now let's just continue our practice. Okay, example number 13. I have a list of limits, and each limit represents the derivative of a certain function at some number a. And we have to identify what is a function and what is a number a. 1, 2, 3, 4, 5, and I have more on my next slide. Okay. Limit number 1. Limit h approaches 0, 1 plus h, we recognize a plus h, 1 plus h to the power of 10 minus 1 over h. I mean, as said, this is definitely the derivative at the number a. But what is the number a and what is a function? Here we may notice is x to the power of 10, 1 to the power of 10, and the number a is 1. Okay, that's how we have to identify. If I will ask my students to set up a definition of the derivative for x to the power of 10 at 1, it will be like this. Yeah, now we're working backwards. Okay, limit number 2, h approaches 0, 1 over x, 1 over 2 plus h minus 1 over 2 over h. Derivative at a, and we may notice right away the a is 2. And function, it's 1 over the quantity x. Okay, limit as h goes to 0, fourth root of the quantity a plus h, 16 plus h, minus f of a. It's 2, but this time we know that this is f of a. And this is derivative at a, derivative at 16, and fourth root of the quantity x. Fourth root of 16, it is 2. Yeah, and fourth root of a plus h, 16 plus h. Okay, now number 4, limit as h goes to 0, 2 to the power of a plus h, 2 to the power of x. I can even start right away. 2 to the power of x. And this is derivative at 5, because this is f of a, 2 to the power of 5 is 32. That's not 32. Okay, and now limits h goes to 0, tangent of pi over 4 plus 4, pi over 4 plus h, minus 1 over h. That's we may guess, educated guess, that function is tangent, and this is derivative of tangent at pi over 4. F of a plus h minus f of a. Let's just check. F of a is supposed to be tangent at 45. Tangent at 45, it is 1. Okay, perfect. We recognize all of these derivatives. I believe I have 6, 7, 8. Okay, but now we are a pro, we are an expert. Derivative at pi, because it's a plus h, and function is cosine of x. The only maybe problem we may have it is plus. We always have a difference quotient, but this number is supposed to be cosine at a, cosine at pi, and cosine at pi is -1, right? Cosine at pi is -1. Let's maybe do this way, and subtracting negative will be positive. Okay, now this is derivative at 1, because it's a plus h, e to the power of x. X is replaced with a plus h, a is 1. This limit, h goes to 0, natural log of e plus h minus 1 over h represents the derivative at e. And function is natural log of x. Natural log at 1, I believe is, oh, no. 1 is the answer. Natural log of e. Because natural log at 1 is 0. E is the a value. Natural log at e is 1. And this one is e to the x, e to the power of 1, e to the power of a. It is e. Okay. And that means also we have to be able to recognize the definition of the derivative and identify what function and what a value. Okay, another example. Find the equation of the tangent line to the graph g of x at the point 5. If g at 5 is -3, g prime at 5 is 4. Okay. And as always, I will definitely recommend to pause the video now and solve this question. Because if we really understand the concept of the tangent line and the derivative, we can solve it like in a minute. Yeah? But if we don't understand, it's a really easy question. If we don't understand, yeah, we may like think. I know that you can solve this question, but please, please pause the video and try on your own. Okay, now you are back. We have to find equation of the tangent line. Yeah? That means it's a standard question. We have a point, the x coordinate is 5, and g at 5 is -3. That's when we will use the point slope form. Point slope form. Okay, y value is -3. This is slope. And x value is 5. That's we just need a slope. And what is the slope of the tangent line? Slope of the tangent line is basically the derivative. Slope is derivative. That's slope of tangent. I mean, that's the whole point. Really easy question if we understand the concept. Okay, but now let's just say isolate y for x. Oh, -20, -23, I believe. Right? Because it's -20, -3, -23. That's the tangent line. That's it. Please, yeah, please always remember derivative at the given point represents the slope of the tangent line at that point. Okay, example number 15. The same thing. Yeah, please pause the video and try to solve it on your own and then come back. If the tangent line to the function f of x at the point 4, 3 passes through the point 0, 2, find f of 4 and f prime at 4. Oh, interesting. Maybe this one I can just draw it something. Okay, I don't know the curve f of x. Let's say this is f of x. But what we know that at 4, oh, my labels, at 4, 3, if the tangent line to the curve passes through the tangent line to the function f of x at the 4, 3. Oh, that's actually good. 0, 2 goes through the point. That's mean. Oh, no. I can't do this way. I have to do it differently. We know that this through that point 4, 3, then I can maybe do a little bit better scaling if I don't have a curve, because I always match the, okay, 4, 3, let's be, and we know that that tangent line also go through the point 0, 2, that point. I mean, I can possibly draw a tangent line. Okay, this is tangent. This is tangent. And since we have 2 points, we can find everything. We can find the slope. We can find everything. Okay, as we have a point 4, 3, and we have another point, like, I don't know, let's say point A, 0, 2. And if f of 4 is basically that value, f of 4 is basically this one, because this is the value of the function at 4. That's we have the answer for f of 4, not extremely like difficult, but we also have to find f prime at 4. And what is f prime? Is the slope of tangent. And in this one, we don't, let's say this is the function. A little bit weird shape, but because I wanted to draw a tangent, that means this is, it doesn't look like a sharp turn. Let's maybe do it more smoothly. I can even say is this, okay, that's the tangent line. But since I will not use any definition, I will just use the rise of the run. Okay. Rise of a run, since I have 2 points, I need delta y, I need delta x, and that will be a tangent. I can use slope of tangent rise over run. Rise is the difference between 3 and 2. We can say right away. And this is between 4 and 0. 1/4. That means 1/4 is the slope here because that's 0. I think this is again the question. Yes, I just want my students to identify that f prime at 4, it's a tangent, slope of the tangent line at 4. And just different scenario, different values, but we got the answer. Okay, not really practice, not really the practice of the definition, however, the concept. Okay, 3 and 1/4. I'm sure looking at this question, you can give me the answer in 1 minute. Okay, example number 16. For the function g, whose graph is given, arrange the following numbers in increasing order and explain your reason. Okay, that's what we have. We have 0. 0 is 0. Okay, then we have derivative at -2, derivative at 0, derivative at 2, derivative at 4. So we have to find out, approximate. That's we will approximate these numbers, and then we will put the order. Okay, I will leave it 0. Now, what is g prime at -2? Of course, is the slope of the tangent at -2. This is -2, and if I will draw a tangent, looks like this. It's steep, positive. That means I can approximate, let's say 3. You can say anything because we just we need to find the order. And that means even if you will identify this as a 4, 5, it's still fine. I just said 3. Okay, g at 0 will be, g prime at 0 is a slope of the tangent line at 0. Actually, it looks like we have to do this way. It's like sine the other one, negative sign. Okay, that means this is slope. It's a little bit less steep, but it's negative. We can approximate maybe -2. Okay, now let's say blue. G prime at 2. It says slope of the tangent at 2. Slope of the tangent at 2. 2 is a little bit less steep than red one, that at -2. We can say maybe 2. It looks like 1 actually. Let's say 1. Okay, but positive. And now g prime at 4 is slope of the tangent at 4. 4 is here. Oh, this one is definitely less steeper. This one we can say maybe half, 1/2. Okay, you can all, based on the slopes, you will identify. Okay, that's mean now let's put the order. The increasing, that's mean we need the smallest number. G prime at, actually maybe I can do this way. G prime at 0. We approximate as a -2, but I don't even have to do it. Let's, comma. Now the next number is actually 0 itself. And then the smallest positive, G, I got used to write F always. G prime at 4, and then 1/2, 1. G prime at 2, and then G prime at -2. That means this was -2, 0, 1/2, 1, and 3. I could. And even if you have different like approximations, because you may have a little bit different like view, everybody's looking differently at things, I'm sure we will match that box. That's the order, increasing order. So please remember again, derivative of the function is the slope of the tangent line. Really easy to apply this later. Okay, and then I have another one. Oh, typical question. Find an equation of the tangent line to the x², but at 5. Okay, we will need point slope. Point is 5. Slope, we need a slope, and wrong, 5² actually, I could say, because if the x value is 5, then function is x², 5². 25. Okay, that means this was, I can put 5 squared and x minus 5. That means this will be 25, and slope is the derivative of the function. Derivative at 5. Let's find the derivative. Limit, only the limit definition is our tool at the moment. F of 5 plus h minus f of 5 over h. And you are an expert with limits. You went through chapter 2. Function is x squared. Then we will have 5 plus h squared minus 5 squared. Direct substitution, it's showing us that is 0 over 0. Of course, it's calculus, instantaneous rate of change. No distance, no time. Okay, let's expand this. 25 plus 10h plus h squared minus 25. Cancel out. And we can see we have 10h plus h. We may factor out h. And now the 0 is gone. The final answer is 10 plus h, but now we can do the direct substitution. It is 10. That means slope, derivative is 5, derivative is 10 at 5, slope is 10. Y minus 25, 10. And when I distribute everything, it's 10x minus 50 plus 25 minus 25. And I think we match with the answer on the graph. Okay, beautiful. Please, please erase everything and do it again. Yes, have your time, have your practicing time. Involve like yourself, yes, in that action. Yeah, just try to learn it. Put the energy to this, not to excuses. Yeah, because we have lots of energy, but we have to use it in a good way. Okay, and then let's maybe do one more, and that will be everything for section 3.1. You will be an expert. Compute the tangent line to the hyperbola 1 over x at 2. We did it 3, I think, but let's do it this one. Okay, I have the solution, but we will do it again. The same thing. Let's maybe start. F of x is 1 over x. F of a plus h will be 1 over a plus h. Let's just evaluate. F of a will be 1 over a. Yeah, the evaluation, always we're replacing x in the formula with the quantity in the parentheses. Now we need f of 2, 1/2. That means the point is 2, 1/2. We're looking at the tangent line at the point 2, 1/2. And the point slope form, 1/2 slope and this. And what is slope of the tangent line? Derivative. Derivative at 2. Let's find out that derivative. Okay, we did a little bit of evaluation. F prime at 2. Limit, h approaches 0. F of a plus h minus f of a over h. Limit, h goes to 0, and then f of 2 plus h minus f of 2 h. Let's replace. Okay, f of 2 plus h, 1 over x, 1 over 2 plus h, minus 1 over x, not x, 2, 1 over 2. And then we have 0 over 0 when we substitute right away 0 instead of h, but I will multiply each term by 2 times 2 plus h. 2 times 2 plus h. I will multiply denominator and I will distribute this in. You remember that part of algebra to simplify lots of fraction bars. We just need one fraction bar. When I multiply the first quantity, 1 over 2 plus h times the blue expression, then 2 plus h is cancelled out. Only 2 will stay. When I multiply 2 times 2 plus h times half, the 2 will be cancelled out. Only 2 plus h stays. In the denominator, I will keep everything. Oh, I don't need really parentheses for 2. That's weird. Yeah, we don't need this. It's not negative. Okay, let's distribute negative, important. 2 minus 2 minus 8. Please remember, the negative in front of the parentheses will affect both of the quantities. 2 and negative 2, and then, okay, and I really need the room. We will have negative h, 2 plus h. Oh, I lost that too. I can put it at the back. Now the common 0 is ready. Let's use different color to be cancelled out. No more zeros in the denominator. Negative 1, and then h is 0. 2 times 2, negative 1/4. Negative 1/4. That's the slope. Let's see. Let's put this negative 1/4. When we distribute negative 1/4, negative 1/4 times negative 2 is positive half, and adding another half plus 1. This is equation of the tangent line. Let's check if negative makes sense. I can draw a function. 1 over x looks like hyperbola in the first and the third quadrant. And we're looking at 2, 1/2. That means slope of this line. Maybe let's use purple. Slope. Oh, it's not really a tangent. Why I'm repeating? Because I'm focusing maybe this way. Yes, that looks better. Definitely slope of this line is negative, and we know exactly it's negative 1/4. Derivative at 2, it's negative 1/4. Okay, beautiful. Now, if you practice all of the 18 questions from part 1 and part 2, you are an expert. Okay, see you next time. Thank you.